Hello and welcome to my channel, The Complete CSC Guide. And I am Sanskriti. Today I am going to explain you about Go Back N ARQ, right? So in the previous class we have seen the stop and wait ARQ, and now in today's class we are going to study about the Go Back N ARQ. Now what is this Go Back N ARQ? As you know that this is also a protocol or ARQ from noisy channel. Okay, so introduction. Go Back N Automatic Repeat Request ARQ is a sliding window protocol used in computer networks. It ensures reliable data transmission by allowing the sender to send multiple frames before receiving acknowledgement. As the name suggests, that Go Back N ARQ means n number of frames we are sending here, right? Since in previous class you have seen that in stop and wait protocol or ARQ, we have done what we have done there. Only one frame was sent, and the receive acknowledgement was received for one frame only. Now here we are sending more than one frame before receiving a acknowledgement. A acknowledgement means single acknowledgement, right, for one frame. Here it is already said that multiple frames, we are sending here multiple frames, right? But what we are doing here is that we are waiting, we are not giving any chance for any wait, we are just giving multiple frames, where the sender is sending multiple frames, but it is not waiting for the acknowledgement. Before receiving an acknowledgement from a single frame, it is going on sending multiple frames. If an acknowledgement is not received, suppose since I am sending so many frames together, if any acknowledgement I am not receiving, the sender retransmits all unacknowledged frames, enhancing data integrity in a network. That is, if any acknowledgement is not received, that is, any unacknowledged frames, whatever frames are there which are unacknowledged, if the sender is not getting acknowledgement, it is not receiving acknowledgement for a single frame, what it will do, it will retransmit all the frames which are not been acknowledged. So here what is happening, acknowledgement for a single frame, right? It is sending acknowledgement, it is not waiting for the acknowledgement. But whenever the sender is not receiving an acknowledgement for a particular frame, what it will do, it will retransmit all the unacknowledged frames. Okay, so enhancing the data integrity in the network. Now Go Back N protocol, what it means, or why it is used, what the concept is, which is it is using, is the concept of pipelining, and is more efficient than the stop and wait. Obviously it is more efficient since it is using the whole channel. Okay, so it is not waiting, it is not just wasting any time, so it is efficient since it is using the whole channel, right? Now pipelining is a general concept in which the processing of the next task begins before the previous task is completed. So we have already discussed this one in the previous class, that the next protocol or the next ARQ will be what, it will be not waiting for the next task, the task is going on. Okay, so if the previous task is completed or not, it doesn't matter, it will again do the next task. Okay, now let's see what's next. So this is all about what is about the Go Back N ARQ. Now here you can see what is happening here. This is a Go Back N ARQ protocol. So this is the flow diagram, right? So you can see here, I have already explained you about the sliding window protocol, what was happening there. Now here you can see what is happening here. The whole thing is, this is a window which you can see there are 10 particular frames. So here total 11 frames. So you can see here the frames. Now what is happening, the window size is 4. Sorry, here you can see what is the window size. So the window size is 4. Now what is happening here, here you can see that the sender is sending multiple frames here, right? So what is the sender doing, it is sending multiple frames, 1 2 3 4. So here these frames have been sent, but you can see the receiver is only giving an acknowledgement. This is the ACK, this is the acknowledgement which is being sent by the receiver. So this is what is happening. So the receiver is sending an acknowledgement for these 4 frames. Since the frame size is 4, so what is the receiver doing, it is sending an acknowledgement. Okay, so it is sending an acknowledgement for the frame. So this one is the ACK, this one is the acknowledgement which is sent by the receiver. So what will be this acknowledgement, obviously it will be for frame number F0. So it should be F0. It should be F1 since it needs the next frame. So whatever this frame, so we have to see what acknowledgement it is getting. So obviously for the first frame acknowledgement is received. Now this is the window size, that is 4. So these 4 frames have been sent. Now let's see what happens next. So this is what is happening here for the first frame, right? So these all frames, so these are the particular frames which are being sent and the acknowledgement is received. Now here, what is this one? That is, what is Go Back N ARQ? What is the protocol? This type of ARQ, automatic request, in which the sender process continues to send the number of frames specified by a window size, even if the receiver does not provide an acknowledgement ACK for the packet. So the receiver is not receiving, it is not giving you an acknowledgement for a particular frame. Still the sender is sending that particular frames. It is going on sending. The process is a continuous process here. It is not waiting for any kind of acknowledgement which is going to receive. So obviously it is going on sending. In Go Back N ARQ, the N is the number of window, that the sender window size is N. That is Go Back N protocol, that is ARQ, that is N is the size of the window, sender window, right? Suppose if we say that Go Back 4, the sender window size is 4. So Go Back N is the name of the protocol, but here N will be replaced by whatever number is your window size. So here if our window size is 4, so Go Back 4 ARQ. It is the concept. What is that is N. The N is the size of the sender window. Then the sender window size is 4. It means it can send 4 frames simultaneously before expecting an acknowledgement from the receiver. But after sending these 4 frames, obviously it will be waiting for an acknowledgement, right? Now, Go Back N ARQ uses the concept of protocol pipelining. That is, the sender can send multiple frames before receiving the acknowledgement for the first frame. There is a finite number of frames and the frames are numbered sequentially. Here, what is the thing? The frames are being numbered sequentially. That is 0, 1 to whatever. The number of frames that can be sent depends on the sender's window size. Obviously, whatever frame the sender is going to send, it will be depending on the window size, since the name that exists, that is the Go Back N. Now N is here is the sender window size. So obviously this will depend on the sender window size. If the acknowledgement of a frame is not received within a certain period of time, again is there, some period of time is there where the sender is going to wait, all the frames present in the current window will be transmitted. So current window, whatever frames are there, they are being transmitted. The sender window size determines the sequence number of the out of bound frames. Now N is the sender's window size. For example, if the sending window size is 4, that is 2 to the power of 2, then the sequence number will be 0, 1, 2, 3, again 0, 1, 2, 3, 0. So obviously it is, we have seen that to 0 to that particular number. So this is the concept, and so on. This is what is going on, right? So sender window size is the main thing which is here. We have written that Go Back N. Now sender window size and receiver window, what are these things? In the Go Back N automatic request, what is happening? ARQ protocol, sender and receiver windows play a crucial role in managing the flow of data and ensuring reliable communication. Now since here these two things are very important, that is the sender window and the receiver window. Obviously, since this is showing you how the whole transmission is going on, or whole transmission is taking place, these two are very important and these are crucial for your reliable transmission. Okay, now see, what is sender window? So the sender window represents a range of sequence number assigned to frames awaited acknowledgement from the receiver. That is, these frames which are in the sender window, these numbers, these frames are those frames which are waiting for an acknowledgement. They are not yet been acknowledged by the receiver. So they are taking place in the sender window, right? Now, frames within the sender window have been sent but not yet acknowledged. The sender retains these frames in its buffer, and as acknowledgements are received, since I am sending the particular frame, I am keeping it in the buffer. Now when the acknowledgement are received, it slides the window forward. The window is being slided forward. A forward slide of the window is taking place, now allowing for the transmission of new frames. Now some new frames are being transmitted now. Okay, for example, in Go Back 4 ARQ, the size of the sender window is 4. As I have already told you, the size of the sender window now is 4. So if it is 5, then go back 5. Okay, so this is the number of N is the number of sender width. What is the frames which are going to be sent? Now, size of sender window. Receiver window, what is that one? The receiver window represents the range of acceptable sequence numbers that the receiver is willing to accept. Now, receiver again have a number which it is willing to accept. It have a number which this number of frames it is going to receive. The receiver uses the receiver window to filter incoming frames. Now, it is also having a filter to that it is receiving some frames. Now, it is having a receiver window which can filter the incoming frames. It acknowledges correctly received frames within the window and discards the out of sequence frames. So, it is discarding the out of sequence frames which are not within the sequence. If some frame is coming, then it is discarding that one. But correctly received frames, it is taking and it is putting in the receiver window. The receiver window helps in reordering frames and detecting correctly transmission errors. So, obviously, it will be helping you to correct the transmission error, right? So, these two windows are very important in this Go Back N ARQ. Now, see here. This is my sender window. Now, from the size, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, this is the size of my window, right? So, here it will be the 12 size. See, this is my whole size window is present. And now, what is my size? Here you can see that here total 12 frames are there. Now, working. How the working is going on? Suppose there is a sender and receiver. There are 11 frames to be sent. 11 frames are there to be sent to 0 to 10. Since it is 11, then 0 to 10. And the frames are numbered as 0 up to 10. Now, the sequence number of the frames is decided by the size of the window size. As there in the previous slide, you can see here, it was of 12, size 12, right? What was the size of this window? It was 12 size. Since here 0 to 11, so number of frames will be 12. Frame size is 12. Now, here, what is happening next? So, here what is there? So, here we are talking about 10. So, the size of frames, there are 11 frames and 0 to 10. The sequence number of the frames is decided by the size of the window ends. For better understanding, we have taken the running numbers. So, let's understand the working of Go Back N ARQ with an example. Now, we will see some example where it will get clear, right? Now, first step is what? Sender's window size. Imagine the sender's window size is 4. We are taking here as the sender window size as 4. This means the sender can send up to 4 frames without needing acknowledgements for each frame. Now, you have to see the sender will have to wait up to the number of frames. So, what is the size of the sender window? The sender have to wait up to that particular number of frames. When it is sending, then it will wait for an acknowledgement, right? Before that, it's not waiting. It's going on sending. Okay. Now, this is the first step. Now, you can see here, we will see the example, right? Here you can see this is my frame. These are the frames. So, 11 size is 11 here. Now, window size is 4. So, here 11 frames are total 0 to 10. But my window size is 4 here, right? So, what will be the window size up to this will be my window size. So, this will be my window size. Now, let's see what is happening here. So, sender is there, receiver is there. Let's start. So, first step, what is happening? The sender, it is showing, this was the whole thing. Now, sending the first frame. The sender begins by sending the first frame, which we will call frame number 0. First frame will be frame number 0. At this point, only frame 0 is within the sender's current window. Now, the sender's current window only have the frame 0. Since the window size is 4, the sender continues to send the next frames from the buffer. So, it will obviously send the next frames 0, 1, 2, 3. Since my size is 4 without waiting for any acknowledgement. It is not going to wait as in the stop and wait protocol. What we were doing? We were sending and waiting for an acknowledgement for a particular time stamp. But here we are not waiting for any time stamp. Okay. So, here we are just sending the frame. Again, since my size is 4, again I will be sending the next frames like 1, 2 and 3. So, here you can see what is happening. Here my sender window size is 4. Right, and here you can see after sending first frame, second frame, third frame and fourth frame. So, 4 frames we are sending without waiting for any acknowledgement. After we have sent the 4 frames, then we will be waiting for an acknowledgement. This is the window of sender window. Now, what next? Step 3 is expecting an acknowledgement. Now, we are expecting an acknowledgement. The sender expects an acknowledgement from the receiver for frame number 0. Why it is expecting an acknowledgement for frame number 0? Since the first frame which was sent like this, it was 0, 1, 2 and it was 3. So it is now waiting for an acknowledgement for the frame number 0, the first frame which we have sent. Okay, now next step, you can see here what is happening next. So this the sender have sent 4 frames. Now this is the acknowledgement which is being received by the sender from the receiver. So it is for frame number 0. So this is what is happening. Now the receiver is sending an acknowledgement. Now the sender is waiting. After this, the sender is waiting. Since these 4 have been sent, 4 is correct. Now it is waiting. Now it is getting an acknowledgement, right? Now what next? Next is the fourth step. This is the acknowledgement which is received. Now frame 0 had been acknowledged. Once the receiver acknowledges frame 0, the current window size becomes 3. Since 0 is now acknowledged, the function of 0, frame number 0 is done. Now the size is becoming 3. Why the size is 3? Since this is already acknowledged. The sender then sends the next frame from his buffer, which is frame number 4, and the window slides forward. Since what is happening now? Now the next frame, it is sliding. Frame number 0 done. Now what is happening? It is sliding now. See, this is done, right? Now it is sliding towards this side. Now this is my next. So what will be happening? Since these are sent already, now after this again 3 things have been sent. 3 frames have been sent. Now I have to send the next frame. So frame number 4 is being now sent. Since I have received an acknowledgement is sufficient. Now I am sending the next frame. Done. So frame number 4, the 4 is being sent. Since these are sent already, so frame number 4 sent. Now acknowledgement for frame number 1 with a current window size of 4, the receiver acknowledges frame 1. Now the receiver is acknowledging again the frame number 1. So 0, work completed, 1. Now what is happening? Let's see. Now the acknowledgement for frame number 1 is being sent. So this was 0 and this is the acknowledgement for frame number 1. It is now sent. So function of this 1 is also done. Now 2, 3, 4. What will happen next? It will go to slide to next. That is 5, right? Let's see. Now what is happening? This is done about this one. Continuing to send frames, the sender sends the next frame from his buffer, which is frame number 5, and the window slides forward. Okay, done. Now, however, let's assume the sender doesn't receive an acknowledgement for frame number 2. Frame number 0, 1, done. But for frame number 2, the sender is not receiving any kind of acknowledgement. Then what will happen, right? So, this could be because frame 2 got lost or the acknowledgement itself was lost. Anything can happen. Either the ACK is lost, either the frame is lost. We have already seen this all things, right? Now let's see what is happening here. So these 2 done, 0, 1 done. Now for 2, what is happening? The acknowledgement is being sent, but this acknowledgement is lost here. So now what the sender have done, it is sent the 5. This sliding window is now having frame number 5. So 4, 5 again sent. So how many frames are now? 2, 3, 4, 5. 4 frames again there. But the sender is not receiving the acknowledgement for frame number 2. This is our current scenario. These 2 have been acknowledgement, right? Now the next frame is frame number 2, which is not acknowledged. Now what will happen? Let's see. Or the acknowledgement is lost. Now what will happen? Timeout and retransmission. This is the fact. The sender waits for a set period. If it doesn't receive an acknowledgement from frame number 2, during this time, it goes back to frame number 2. Now it is going back to frame number 2. Whatever things we have sent doesn't matter. Now let's see. It then transmits all frames in the current window. 2, 3, 4, 5. Already up to 4, 5 we have sent. But since the acknowledgement is not received, we are not getting the acknowledgement for frame number 2. Again it will retransmit these frames, that is 2, 3. Since its window size is there, not 2, 3, 4, 5. Now it will again retransmit, even though frames 4 and 5 have already been sent. It had already been sent, but still it will retransmit. This retransmission ensures that all frames are received correctly, including the ones that might have been sent previously but not acknowledged due to the issue of frame number 2. Now since they have not been acknowledged due to this frame number 2's acknowledgement have been not received, so these all things will be again retransmitted. This is what is Go Back N ARQ. Go back and you please send those N which have not been sent. This N is the sender. Now you can understand. Gradually we'll understand what is the concept. This is the concept that now ARQ, that is Go Back N ARQ, what is happening now? you go back and send those n, that is the size of the window. What was the size of the window up to this, which is not mean acknowledgement, just send these all things, right? So what is happening here now, you can see that this up to this it was okay, right? This up to this thing is what's okay. Now 2 is not sent, so what is happening, 2 3 4 5 again they will be, so up to this 2 3 4 5, so these 4 5 are again discarded. Now again it is sending this 2 3 4 5. Now this is the scenario, that is this 2 3 4 5 is again been sent, so these are been discarded. Since these acknowledgement is not received, discarded. This is the thing which is go back N ARQ is the main thing is there. Okay, now characteristic, what is the characteristic? The following are the characteristic of the sender's window size in go back N ARQ is this n is the sender's window size. You have to understand this one and you have to memorize this one, that this n is the sender's window size. The receiver's window size is always 1. Okay, now if the sender doesn't receive an acknowledgement for a single frame, it retransmits the entire window beginning with the problematic frame. Problematic frame means that frame which have not been acknowledgement, that is my problematic frame. So whole window will be again retransmitted. So this is the characteristic of your go back N ARQ. Now advantage, the following are the advantages. In go back N ARQ, when a sender detects that a frame it had sent as a corrupted, example due to transmission errors, it doesn't just retransmit the corrupted frames, instead it retransmits the entire window of unacknowledged frames starting with the corrupted frames. So you are getting the chance of error is very less, since it is sending, it's more efficient from stop and wait, since it is giving you a whole, it is just retransmitting the whole window, right? So error will be less here. It allows the sender to send multiple frames consequently, so that without waiting for acknowledgements after each frame. Okay, so it is just going on sending the frames, it is not waiting for an acknowledgement. It's very much efficient. Now pipelining is present, which means that the sender can send a continuous stream of frames, right, within the window without waiting for an individual acknowledgement. This is what is the profit or what is the advantage. Now what is the disadvantage? If acknowledgement of one frame is not received, the entire window have to be retransmitted instead of only giving the corrupted frame. So obviously it is efficient, but what is the disadvantage? That it have to send the corrupted frames. Obviously it's good, but the frames which are not corrupted, it have to send those frames also, so it is time consuming also. Retransmitting the entire window on detection of a corrupted frame increase the congestion and time consumption. So obviously it is time consuming as well as it is increasing the congestion. So this is what is happening in, this is the disadvantage of your go back N ARQ, right? Now here what was the limitation of our stop and wait protocol? Here you can see that inefficient of a stop and wait, but because the channel is left idle without use until an acknowledgement is received. There what was happening, until an acknowledgement is received, we were waiting for an acknowledgement, and it was also very time consuming, or also it was making the channel inefficient, very much inefficient. Thus the allowing the transmitter to continuous sending enough frames that the channel is kept busy while the transmitter is waiting for an acknowledgement. So this was the limitation of stop and wait protocol, right? So which is being, now we are just correcting that one and getting this particular protocol, the ARQ, that is our go back N ARQ. But it is also a limit, it is efficient, obviously it is efficient, but it is also having some problems. Now here you can see an animation which will clear you that whatever things are there in your mind, it will just make you a understanding, clear understanding. Now here you can see an outstanding frame, it is a frame that has been transmitted and is yet to be acknowledgement. Here let's see what is happening. So first of all, you can see here the sender and receiver is there, right? Now next let's see what is happening here. First of all, see, frame number 0 is being sent. Now after frame number 0 had been sent, no acknowledgement will be received. Obviously no acknowledgement will be received here. Now next 12 bit happened. Now the frame number 1 is sent. Since it's not waiting for an acknowledgement, and our here the window size suppose 4, so obviously it will send the next frame, frame number 1. Then what will happen next? It will send the frame number 2, next frame number 3. But what is happening here? Here also some typical thing is there, that is 0, 1, 2, but my frame number 3 is now getting missing. My frame number 3 is corrupted or it is lost, right? Now what will happen? The receiver is sending an acknowledgement for my frame number 1, right? Sorry, frame number 0, but it is sending 1. Why? Since it's in this acknowledgement, what we have already studied, that what frame next it is expecting, it will send that one. So ACK 1 means it is sending an acknowledgement for my frame number 0. Now next what will happen? Frame number 4 is sent. Since my frame number 0 had been acknowledged, now my frame number 4 is sent, since the window size have to be 4, right? Now next what is happening? This is what acknowledgement 2. That means my first frame is frame number 1 is also acknowledged. Now I need a acknowledgement 2, means I need frame number 2, but already frame number 2 have been sent. So now my window size is again it is 3. So I have to send again a frame, that is frame number 5. So let's see what next happens. Frame number 5 sent. Now next what will happen? Let's see. Now acknowledgement, I have received an acknowledgement for frame number 2. Now my window size is again 3. Now I have to send frame number 6. Now let's see what is happening. Here frame number 6 is sent. Done. Now what is happening? Now my frame number 3 is there, which is lost. So obviously receiver will not send me any kind of acknowledgement. Now let's see what happens. Okay. So now here out of sequence frames, so do not accept them. Since frame 3, here what is happening? That is my frame 3, since it is lost, so obviously I will not receive any kind of acknowledgement. Now what will happen? The receiver will give you an out of sequence frame. So these are my out of sequence frames. Which are my out of sequence frames? 4, 5 and 6. Since these are not accepted, these are out of sequence frames, that is they are not accepted, since frame number 3 is not received by the receiver, it is not acknowledged. So these frames are out of sequence frames, right? Now let's see what's happening next. At this point there are WS, the size of the window is 4, outstanding frames, so go back 4. Since your window size is 4, go back 4. This is your particular protocol. Now your particular ARQ is go back 4, not go back N, since your window size is 4. So these are now my out of sequence frames. Now let's see what is happening next. So this is what is the scenario now. Now what will happen? That go back 4 means I have not received acknowledgement from frame number 3. Now you can see here 3, 4, 5, 6. This all frames will be sent, right? After sending these frames 3, 4, 5, 6, it will wait for the acknowledgement. Now it is receiving the particular acknowledgements for 4, 5, 6, 7. Now it is sending the 7th, 8th frame. So now it is continuously going on correctly, perfectly. Up to this, since the error was there, some corrupted frames were there, so it was again retransmitting. The main concept is it will be retransmitting all the frames, which after this corrupted frames, the corrupted frame will be sent, and all the frames present in the window, that will also be retransmitted. So this is what is happening here. Okay, for your clear understanding, you can see this particular animation, or from this you can easily understand what is happening here. Now next, so this is the go back N basics. Transmit without waiting for ACK. Each frame received correctly is acknowledged with a sequence number corresponding to the next frame expected, right? Since if ACK 1, that means, sorry, ACK 1 means what? Here ACK 1 means my particular ACK 1, my frame number, if it is 0, my acknowledgement will be 1. That is my next frame number. So again, if my frame number is 1, So my ACK number will be ACK2. So the next frame number is being sent in the acknowledgement. Now the receiver discards all out of sequence packets. It will discard if some corrupted frame is detected, then it will discard all the out of frame or out of sequence packets. If number of outstanding frames is WS, that will go back N. Means WS is the window size, so go back N will be that particular size. That N will be size, that is WS, like your size of the window. So it is what is happening here. Now let's see the next thing. Okay, so what is WS? That is the window size. So it's the sender window size. Each frame must be buffered, stored. Okay, so let's see the previous one. Now here. Okay, so here what is happening? The WS, that is your window size. So sender window size, each frame must be stored in a buffer. Okay, so buffer that is stored until a valid ACK arrives in case retransmission is needed. Since why it is buffer, since it is stored in a buffer, why it is stored? If any kind of corruption is there, any kind of corrupted frame is there, so case of retransmission, we are just storing these frames in the buffer. So WS means the window size, represents the maximum number of frames that may be outstanding, that is stored simultaneously. So the buffer will obviously held up to 4 frames, right? Now next, sliding window concept. Now we have already studied the sliding window concept. Go back N is an example of what is called a sliding window protocol. And ACK received means that all previous frames have been received correctly, right? So ACK received means what is the acknowledgement? If I am receiving an acknowledgement from frame number 2, that means all the other frames 0, 1 have already been received perfectly, right? Now that is the main concept here. So previous ACKs were lost or received, and ACK received means all the previous frames have been received correctly. Previous ACKs were lost or receiver choose not to send them. That is the concept. Now here you can see a sliding window, sending window, that is frame 1, frame 2, frame 3. So obviously the window size is 4. Now here you can see that the first thing is the first particular frame is sent and ACK is received. Again frame 1, frame 2, frame 3. So this particular sending window, it is sending up to frame 3. Then it is receiving an acknowledgement for frame number 0, 1, 2 up to this. Now after that frame number 4, 5, 6. So it is waiting for the acknowledgement after the window size, that sending window size. If it is 5, then it is after sending 5 frames it will wait for an acknowledgement. If it is 6, then after sending 6 frames it will wait for an acknowledgement. So this is the concept here. This is what is sliding window concept. So again here you can see now the frame number 1, since you can see here sending window 0, now 1 is sent, then 1 is done. Here it is in blue, so that means 1 is sent. Now next 2 is sent, so obviously 2 is blue now. Okay, now here again next will be the 3 one. So 3 is now sent, so 3 is blue. So this is the main basic concept, is that whatever things are there in the sending window, it is sent one by one without waiting for an acknowledgement. So it is the main thing. Main purpose of this protocol is not to wait. Now again, now sending the frame number 4, since 0 is acknowledged, 0 is now, so you can see that it is gone from the sending window, right? It is not here. Why it is not here? Since it has already been acknowledged, now it is gone. Now next is frame number 4. So frame number 4 is being sent. Now what is happening next? Let's see. Now frame number 5. Since I have received acknowledgement for frame number 1, done. 2, 3, 4, 5. Now again it is just sliding. Sliding window means the window is now the whatever thing are there in the sender window. Now the frame there, that is sliding. Number of frames it is will be n, but the sliding window means the sender window is now sliding towards next frames. Okay, so now you are seeing the change in this sending window. Now again see frame number 6, 3, 4, 5, 6. This is the new window size. Okay, or the window frames, that is 3, 4, 5, 6. Since I have received an acknowledgement for frame number 3, that is your frame number 4, we have received up to 0, 1, 2, 3. Now here we are sending, again it will be n equals to 3, but since our n equals to 4, so it is sliding towards 6. Up to frame number 6 it is sending. So like this thing goes on, and acknowledgement is now received for frame number 4. Now it will slide towards frame number 7. So this is what is happening in our sliding window concept, right? So this is what is there in your Go Back N ARQ. The whole sliding window, the whole Go Back N ARQ, this is the whole scenario, right? So basic concept is here, the main thing, which is your sender window size. That particular sender window size will be your Go Back N, that particular N. So this is the concept of your Go Back N ARQ, where we are using the sliding window concept. It is very important in your this particular Go Back N ARQ. Sliding window concept is very important, since this sliding window will be showing you, this will be shifting towards next frames. If any frame is corrupted, whole thing will have to be retransmitted. But next protocol, what we will see, there we will see that this problem can be solved. This is also a disadvantage which have to be solved. Since the corrupted frame is retransmitted, is okay, perfectly okay, but our channel is also efficiently used, since we are not waiting for an acknowledgement, we are going on transmitting. So obviously the channel is being used simultaneously, but a particular disadvantage is there, that we have to send all the frames, whether they are correctly sent or not doesn't matter. If any corrupted frame is found, then all the frames in the particular sender window have to be retransmitted. How we will correct this problem, we will see in the next class. So I think that whatever I have taught you today, you have understood that one. If you have any kind of query, then you just ask me those queries in the comment section. If you have any suggestion, you can give me that also in the comment section. And if you like my channel, then please give a like, subscribe, and you share this with your friends. And till then, take care and goodbye.